We are Team GUGUGU and members are Boy Chen, Yuchen Cao, and Wenyu Liu. Our question and answering system can be divided into three components. First is coreference resolving. Second is question generation system. Third is question answering system. Let's first come to the first component, coreference resolving. Coreference refers to the mentions of the entity in a text. For example, Radiohead and they, in the same context, both refer to the band Radiohead. In order to improve the accuracy of the questions and answers and also make them more reasonable, we conduct coreference analysis on our input article. Eventually, we substitute pronouns in the article with their representatives. We can benefit a lot from the corref analysis for our system. For the questioning part, after replacing pronouns with the corresponding entities, we can better eliminate ambiguity in the questions. For answering part, replacing pronouns makes sentences relatively independent, so we are able to limit the searching scope to single sentences. We utilize Stanford Core NLP Coref annotator for core analysis. Here are some different modes of resolutions, which are deterministic, statistical, and neural. Each model has its own pros and cons. Out of the consideration of tons of correct analysis per article, we choose deterministic mode to achieve a balance between good performance and small amount of running time. Now let's come to the second part, question generation system. The question generation system takes an article and the number of questions to generate as input. It will generate yes or no questions and WH questions. The first step is to use our coreference resolving component to substitute pronouns with the representatives. Thus, we can get the transformed article without pronouns. For yes or no questions, we apply several transformation rules into each sentence. We use word tokenize to extract the text of our words and try to find the verb tag corresponding word. After that, we use notebooks to analyze the linguistics of verb. With this tool, we can check the tense and person attributes and whether the verb word belongs to BE form. Thus, we decide the start of question to be do or yes or worse or anything else, and do replacement to generate yes or no questions. For WH questions, we want to guess the entity of the nouns in our sentence and decide whether it will be a who, or where, or when, or what question. We utilize the Stanford named entity recognizer with the shorter form of NER to analyze entities in each sentence. This library can find 4 types of entities, like person, or time, or place, or organization. We then do a transformation to generate WH questions. Now let's come to our last part, question answering system. The answering system takes an article and a list of generated questions related to the article as input. It will produce answers for each of the questions. The materials are from Wikipedia, which are mainly well-written introductory articles. We found that dividing the article into sentences and returning a single sentence that contains information should be enough to make most answers fluent, correct, and conscious. So the main goal of our answering system is to return the correct sentence. The main focus is on retrieving the correct sentence. We will detect answer types from the question. We derive the answer type using some handwritten rules. The answer type will be used to match potential answers retrieved from the articles. Then we need to retrieve a bunch of potential answers from the article. The first step is to substitute pronouns with the actual representatives using our coreference resolving component. We would also want to remove stop words so that the result will be more relevant. Then we search through the entire article to retrieve the most relevant sentences. We implement this functionality through a search engine library, SOAR. Finally, we get the top 5 sentences from the article. The last step is to rate potential answers and return the most probable answer. We will take into consideration the relevance of this sentence, considering TF-IDF and the number of entities, matching the answer type in each sentence. We use Stanford and Core NLP to do entity recognition. And last is the tools and packages we use. We use Stanford Core NLP, NLTK2, SOAR Solars 2, and notebooks. That's all. Thank you.